Hi friends, myself Gobin. Today we discuss further transformer related interview questions. So, first one is, what are the types of cooling system used in a transformer? Basically, there are 7 types of cooling system used in transformer. One is ONAN, oil natural, air natural. Basically, radiator are provided in this type of transformer. ONAF, oil natural, air force, radiator with cooling fan is provided. OFAN, forced oil circulation type. OFAF, oil force air force, forced oil circulation type and forced air cooling type. OFWF, oil force water force. Then ONWF, oil natural water force. Also one thing is air natural type cooling system also used. So these are the basic cooling system used in transformer. Then accordingly, as per cooling system, the OTA WTA setting also accordingly changes as per cooling system. When you use ONN and ONFF, at that time OTA alarm setting is 90 degrees centigrade, trip setting is 105 degrees centigrade, then WTA setting 105 degrees centigrade, trip setting 135 degrees centigrade. When we use OFF, at that time OTA alarm setting is 85 degrees centigrade, tripping setting is 100 degrees centigrade. Then WTA alarm setting 105 centigrade, then tripping setting 135 degrees centigrade. So friends, according to the voltage range, here we also check the BDV, breakdown voltage of the oil. So when voltage range is up to 60 kV, at that time the breakdown voltage of the oil breakdown voltage is up to 30 kV. When it is high voltage up to 245 kV, again the breakdown voltage of oil is 40 kV. When again we use voltage EHV, extra high voltage, greater than 245 kV, at that time the BDV is 50, greater than 50 kV. Okay. So again we discuss how many earthing are provided to a transformer. Basically, there is 4 earthing is provided, 2 earthing is for body, again 1 earthing is provided for neutral earthing, and other earthing is provided for LA earthing. Again, if someone asks you why neutral earthing is necessary, why neutral earthing in transformer is necessary, why neutral earthing is necessary in a transformer? Because neutral earthing, due to neutral earthing, it stabilizes the high fault current and it maintain balance voltage in the secondary side. If we remove the neutral earthing, the secondary voltage will be unbalanced. there is no stable voltage in the secondary. If any unbalanced current flow in one circuit in one phase, that will distribute in other two phase. That's why we provide neutral earthing, grounding to the neutral. It protects the equipment and maintains stable voltage in the secondary. Okay. Next one is, someone asks you some important parts of transformer, like, so someone asks you what is breather? What is breather? Breather means the breathing system of a transformer. So how it is work? Now when the transformer oil is heated, again it expand, it move upwards to the conservator. At that time the air is outward to the atmosphere through the breather. The breather is connected to the conservator. Again, when the oil is cooled, at that time there is empty space in the transformer tank. Again, it takes some fresh air into the transformer. It is just like a breathing system, just like human body, we are taking air into our body and air out to the atmosphere. So like that, the breather is doing this type of activities. So again, there is a inside a breather, there is one material that is called the silica gel. Again, question comes, what is the role of the silica gel? What is the function of silica gel? Why we use silica gel inside the breather? The basic function of the silica gel, that is also called the calcium carbonate. The basic function of the silica gel is it absorbs moisture from the air. When the fresh air is enter into the breather, at that time it absorbs moisture from the air and allow the dry air into the transformer. This is the basic function of the silica gel. Its color is normally blue color. So when it absorbs moisture, it becomes pink. When the silica gel is became wet and absorb moisture, after some days it becomes pale pink. So again we dry them, it became also blue. So this is the basic question regarding breather. Again also someone asks you, what is conservator? What is conservator? Now what is conservator? Now it is a tank which is fitted on the top of the transformer. It is just like a reservoir. Again when the oil is heated, at that time it expand and move upwards, store in a conservator tank. Again when the oil is cooled, again it come down to the transformer. So it work as a just a reservoir. Then come to Buckau's relay. The Buckau's relay, the name we know it is a relay. So it is a gas actuated relay. What is the function of the Buckau's relay? Then the function of the Buckau's relay is to protect the transformer from any internal fault, any insulation damage of the winding, or any gas formation in the transformer, or oil level, decrease in oil level. So at that time the Buckau's relay is tripped, the breaker automatically protect the transformer. Then come to further type of loss. One is constant loss, another one is variable loss, that is called the copper loss. The constant loss is remain constant, okay, but the copper loss is variable according with the load. That is also called I square R loss. So how to find out copper loss and the iron loss? The copper loss and iron loss. The copper loss is, how to find out copper loss and iron loss in a transformer? The copper loss is find out by the help of short circuit test, and the iron loss or constant loss is find out by the help of the open circuit test. Okay. So how to reduce, again, how to reduce hysteresis loss and eddy current loss. So eddy current is reduced by the help of lamination of the core. If we laminate the core, again the thickness is varied, so the eddy current loss is minimized. So hysteresis loss is depends upon the core material. So when we added silicon, or when we select as a silicon steel is a core material, so that will reduce the hysteresis loss. Then come to what is voltage regulation. Voltage regulation means the change in the secondary terminal voltage from no load to the full load. That is called the voltage regulation. So when we change in voltage in the secondary by the no load voltage divided by no load voltage, that is called the regulation down. When we change in terminal voltage by the loaded terminal voltage, that is called the regulation up. Then when, so someone asks you, is there any effect of power factor on transformer regulation, voltage regulation? Yes. In case of lagging power factor, at that time the terminal voltage is reduced, so that is called the positive regulation. So in case of leading power factor, at that time the terminal voltage is high, that is called the negative voltage regulation. Okay. So efficiency of the transformer is in general efficiency equal to output by input. Output by input. So whenever we calculate the all day efficiency, that is called the normal general efficiency. When we calculate the all day efficiency, the output in kWh, output kWh by input kWh into 24 hours, in a time period 24 hours, that is called the all day efficiency. whole day efficiency. Okay, so again also there is some silly question. So when the full load copper loss is 400 watt, so what is the copper loss at half load? Simply, when the load is half at that time, that is 1/4. 1/4 into 400, that is 100. Again, when the loss is given, half load is 100 watt. When it is calculated full load, again it is 4 times, that is 400 watt. But the core loss is constant. That doesn't depend upon the load. Then come to the losses, that is copper loss, iron loss. The maximum efficiency occur when the iron loss equal to the copper loss. Again some question related to the parallel operation of transformer. When two transformers operated in parallel having the polarity is changed. Two transformers having different polarity when we connected in parallel, at that time there will be circulating current flow through the transformer coil that will overheat the transformer winding. That will also create a problem. Again two transformers connected in parallel, when the voltage ratio is different, it is also create a problem. The unbalanced current flowing through the primary winding, that will create also circulating current, overheat the winding. Again question, when the phase sequence is changed, so what happen? When phase sequence is changed during parallel operation of transformer, what will be effect to the transformer? So each cycle the two phases short circuited, that will also create a problem. So friends, this is the today interview question. So if you like and share my video, I will be happy and create more video. Thanks.